Dear colleagues, hello. We are happy to see you at the pre-flight conference of the main and backup crews for the ISS 4849. I would like to remind you that we just finished the meeting of the Commission, which discussed the readiness results of the prime and backup crew, their readiness for flight, and recommended them to continue pre-flight preparations at the Baikonur Cosmodrome. Again, presenting the crews whose training we have been following closely, including last week. As we all know, the flight will be flying the new modification of Soyuz MS prime crew. Commander for Soyuz is Anatoly Ivanishin, Russia, Roscosmos. Flight Engineer Takuya Onishi, Japan, JAXA. Flight Engineer 2 Kathleen Rubins, US, NASA. And the backup crew, Commander for Soyuz Oleg Novitskiy, Flight Engineer Pesquet, ESA. As you know, the launch is scheduled for June 24th from Baikonur. Let's proceed to our press conference. Please, your actions. I have a question from the Interfax news agency. Mr. Ivanishin, you will be flying the new modification of the Soyuz vehicle. Can you talk to us about your flight and the emblem for your flight as well? Hello, thank you for your question. Yes, we have the emblem, and I'll be happy to show it to you. Here, I think that will look better this way. This emblem depicts our new flight, Soyuz MS, which will deliver the crew, most likely us, to the ISS. On the perimeter of the emblem, we have last names of the crew members in their native language. We also have 01. This is the number of our vehicle. And then you have the little red circle inside the 0, which is the red planet Mars. That means that our flight is a small but a very important step towards flying eventually to this planet. Maybe not tomorrow, but at some point in the future. The design of the patch has been performed by the Spanish designer by the name of Jorge Cantas. Thank you very much, colleagues. Other questions? Ekaterina Beloglazova, Russian Space. Anatoly, last time you flew Soyuz TMA, that was the last vehicle in that series. Now you are looking at the very first flight of the new series vehicle. There will be a lot of checks and tests in that flight. Can you tell us the main actions that you will be performing during the approach and also further work? Thank you for your question. That is true that my first flight was performed in the last vehicle of Series 200, as we call it. Then we were supposed to fly also the last flight of Series 700, but things changed. Soyuz MS was initially scheduled to launch in March of 2016. Due to various technical reasons and issues, the launch was delayed. Rather than delay the flight of the crew, also, the decision was made for us to fly on this vehicle. How did this come about, this new modification? It was necessary to replace some of the equipment of the ground stations, including Kvant and Kama systems. That is the command radio link equipment. The system named Kama is responsible for controlling radio objects. There were certain difficulties for supplying the analog equipment for the control equipment. So, therefore, it was decided to design a new modification. The work was done. The preparation work was done also in the GCTC and mission control. What are the main differences between this vehicle and previous modifications? First, we have the so-called YKTS system, which replaces the Kvant system. The initial Kvant system was designed to send commands to the vehicle and sometimes to be a backup for the communication channels. The new system includes a telemetry capability as well as being the backup communication channel for the station and even file transfer. Because the ground infrastructure has a hard time keeping up with the new modifications of the vehicle, not all of these functions will be available. Maybe Oleg will be luckier than us in his flight. The new equipment for the core system has been installed as well. This is the equipment that is designed to support the approach and docking of the vehicle to the station. We have new equipment. Things are easier in terms of many components being manufactured in Russia. We have only half the number of the antennas that are necessary to support a robust functionality. Now we only have 3. We also introduced the satellite navigation equipment to the functionality of the system. And so we use satellites for comm. So it's a very self-sufficient system with course, with GPS, and it allows us to calculate the burn magnitude and support the approach and docking. The transmitter has changed as well. The television system transmitter, it's digital, which is very important while performing the final approach and docking at 8 kilometers range. We can perform the vehicle-to-vehicle comm, sending the coordinates to the vehicle of various satellites, the state vector of the station that we receive from the navigation system of the station, and that all is sent to Soyuz, and Soyuz has its own state vector also transmitted to it by the satellites. So that allows us to increase the precision of relative positions of the 2 vehicles. We also have the new digital control unit for the attitude control. It's digital versus analog from previous equipment. The older functionality allowed us to build the 3-axis attitude by performing a number of double-axis rotations and translations. Now, we have 3 axes that allow us to perform this work. And another important change was related to the final approach thrusters. We used to have 2 control loops and 2 manifolds, which were independent and not interchangeable. At this time, with the new modification, the approach thrusters have been eliminated, but instead we have 2 robust and full functionality manifolds that support all these functions. This decision was made to the reason that we needed to be more precise with the attitude control, and also we have a good backup system for both translation and rotation. If you remember, the crew for TMA-19M, which we were a backup for, while docking to the station, had a situation where, due to the signal, the false signal that was received by the vehicle that the thrusters were not functioning nominally, there was an automatic back away from the station. So Commander Malenchenko had to manually override that function. Now our vehicle will not repeat this situation. The second manifold for the approach thrusters allows us to have additional backup functions. Also, this will be very helpful in case we need to perform a quick descent. Our vehicle has two control lines for that. So to summarize, our vehicle became more interesting, more reliable. I'm not a specialist, but it looks, the new modification of the vehicle looks exactly the same as the old one, but the internal workings of it have changed significantly and for the better. We will have various tests and flights, such as a manual approach, where we will be using both the discrete and the analog mode to test the various manifolds of the thrusters. We will be using the rotational control handle and translational control handle to see how the vehicle responds to various commands. Japanese agency, I have a question for Mr. Onishi. As far as we understand, as we have heard in great detail, for the next Soyuz flight, the vehicle modification will be completely different. Have you had any difficulties while preparing and training? Do you have any interesting stories that you could share? Also, how do you feel when you're almost done with training? Do you feel prepared for the launch? Especially the short duration flight versus long duration flight. That would be interesting to see. Thank you. Thank you for your question. First question was related to the difficulties during training. It is true that we trained with the previous crew while preparing for flying on the old Soyuz modification. Then things changed, and we were training to fly on the new mod, Soyuz MS. Now the systems are different, a lot of them, but from the crew standpoint, the difference is not that significant. Again, there are differences, but not that great as far as the crew is concerned. So the training was successful. We trained in April and in May, and we worked hard. We passed our tests very well with high grades, good results. So I think the training was very successful. I am very glad that we passed our tests and we are fully prepared for flight. Space flight has been my dream since I was a child, so I hope that every stage of our flight will be important and interesting. That's all I had. Thank you. Thank you very much. Next question, please.
You look so pretty cool. Why have you decided to become
That's a good question. I did not exactly decide to become an astronaut. It was more like a dream when I was 5 or 6 years old. After that, I decided to become a biologist. It was very interesting for me to see how our immune system reacts to problems with viruses attacking the body. I had a real laboratory. I was a professor. A friend of mine found out about the possibility of becoming an astronaut. NASA performs crew selection every 4 or 5 years, and so she found out about that, and she said, maybe you should try. And I said, no, that's not going to happen for me, I'm pretty sure. But then I decided, why not apply? And after that, I think it's good to have. It would be good to have a scientist on board because we could perform a lot of scientific experiments. So we need pilots and we need various specialists and to have scientists on board. So I'm glad that I decided to apply. Thank you so much. Next question. Amuri newspaper for Mr. Onishi. The token for the flight is the toy bear of your daughter. Why did you decide to use that? And how do you feel about flying with a toy that comes from your daughter? Also for the commander, what do you think about the token that you chose? Yes, thank you for the question. It's true that we have a toy here from my daughter. That's her favorite toy. She gave it to me, and I'm happy that our commander allowed me to select this for our crew. My daughter is also excited that her toy bear will fly in space very soon. I wanted to show it to you today, but unfortunately, it's already quarantined to prepare for its flight, and so I cannot show it to you today. I apologize. Traditionally, the indicator of weightlessness is a toy from a child of one of the crew members. Now, he doesn't have any kids. My son is 23 years old, and his toys are very big and heavy. And more importantly, he won't give them to me. So we are very lucky to have our colleague Takuya-san, who came to our rescue. Interfax News Agency. My question is for all crew members. Could you tell us about the experiments that you plan to perform on board of the ISS? Yes, of course. We are planning to perform a wide science program on board. Some of the experiments on the Russian segment are Odd-click technical experiment, for example, which is intended to study the response of breaking up the meteorites with tiny microscopic particles to obtain information about their decay and their distribution. We could use coverings, elements of the vehicles that have spent a significant time in space, such as solar rays. This technology allows us to use a dozen sensors sensors that are installed internally to the service module. These are the electric sensors that register the impact locations for the micrometeorites and the particles against the insulation of the vehicle, and it allows us to also study the possible penetration locations. Another experiment is BART experiment that allows us to see how things function nominally on the board, and also see how we can fight possible loss of pressure integrity. One of the functions that allows us to do that is ultrasound. And we will be performing the Orbita technical experiment that will allow us to study the light reflected from the Earth in order to increase the efficiency of electrical generation on board ISS. So right now, the solar rays are tracking the sun and only use the direct solar light, but it is possible to use the reflected light as well. So we will be rotating the solar arrays at some point specifically to point at the Earth and see how much electricity we can generate by using the reflected light. We will be studying the range of functionality for the solar rays. Now, biopolymer experiment is directed to creating new polymer materials that are capable of withstanding the biological disintegration. Some of the equipment external to the ISS has microbiological contamination where there's bacteria and fungus growing externally, which leads to the biodegradation of polymer coatings and also of gassing from the microorganisms that are toxic to humans. So we are trying to develop such a structure for the polymers that are not susceptible to this influence. We also have the Vizier experiment and Vizier U. The equipment is infrared equipment that allows us to receive the information in real time on the location and movement of the crew members, as well as the equipment on board of the ISS. The equipment or a person wears a special infrared sensor, and various sensors located across the ISS measures the movement and tracks the movement. That's important for various situations, such as off-nominal situations or extravehicular activities. Vizier U, or U, U stands for ultrasound, is intended not for determining the coordinates, but mostly for determining the rotational angles for various pieces of equipment, such as video or still cameras, and that allows us to build on the Sigma equipment, which gives us information of where we're flying. Using this equipment, the crew gets the ability to determine the coordinates of the locations that we are performing the photo and video imagery for, on the one hand, and sometimes it's very difficult, especially if there are no specific points that would be very characteristic for a certain location. This equipment allows us to, if we know the station coordinates and the angle of the lens, will allow us to calculate the coordinates on Earth that we are monitoring. Yeah, it's also voice command activated as well. That's one of the functions. There is another interesting experiment, control, which is designed to study the gas distribution, or rather understanding the atmosphere of the ISS. The station has its own atmosphere, which is built based on the results of station life. And so we use sensors in order to determine the gas distribution, pressure, etc. So we will study certain events and how they impact the internal atmosphere of the station, such as during the extravehicular activity or approach and docking. I have a bunch of other interesting experiments. If you would like to hear more about them, I will be happy to share. Next question, please. TVS television company, you have a lot of work, but as a person who always wanted to fly in space, what would be the first thing that you would do? And also, if you could repeat that in Japanese, that'd be great. Thank you.
まず日本語で、ずっと子供の頃からの夢が宇宙へ行くということでしたので、私自身すごく今回の打ち上げ、それからその先の長期滞在をすごく心待ちにしています。で、私に課せられる使命というのは、いろんな側面があって、例えばロボットアームを使用した、貨物船のキャプチャーですとか、あとは可能性によっては船外活動の実施ですとか、それのサポートだったり、あとは各種の宇宙実験の遂行だったりするので、それらの使命を確実に果たして、元気に無事に帰ってくることが、今の私の第一の目標です。以上でよろしいですかね。
My answer is that spaceflight has been my dream since childhood. And my goal right now is to perform all the tasks and achieve all the objectives successfully. For example, our flight program will be very busy. We will receive several cargo vehicle flights coming from different countries, such as the US, Russia, and Japan. And so we will be using the robotic arm to bring them to the station and have them dock. We will also perform a number of EVAs, and we don't know who will be doing what task at this time, but we are prepared. And of course, on board, there are a lot of experiments right now. So I hope that the results of our flight will be very beneficial for science in general.
Japanese news agency Kyodo. My question is to Onishi-san. You will become the 11th astronaut from Japan, and it's far beyond Russia and US. But how do you think, how can you contribute? How can Japan contribute to ISS mission in the long term? Thank you.
May I answer in Japanese and then in Russian?
日本というのは小さい国ですけれども、宇宙開発の中ではアメリカとそれからロシアに次ぐ第3位の位置につけていると私は思っています。で、日本らしい確かな技術力を武器にして、例えばコウノトリという補給船だったり、それから希望モジュールのですね、エアロックという非常にユニークな施設を使って日本らしいオリジナリティのある貢献を今国際宇宙ステーションのプログラムで果たしています。ですので私も引き続き日本人宇宙飛行士の先輩方が築き上げてきた それらの実績を受け継いで、さらにその先に、自分が新たな実績を積み上げられるように頑張っていきたいなと思っています。以上です。
My answer was as follows. Our country is small, but it has technologies. By using technology, we designed a very good equipment, such as HTV, the Japanese cargo vehicle, as well as the Japanese module. We have unique equipment. For example, airlock. It's a very unique piece of equipment. Thanks to that, we can perform the airlock allows us to perform experiments outside the station. By using these unique technologies, Japan and Japanese crew members continue working very successfully on board of the ISS. Dear cosmonauts and astronauts, my question is for everybody, mostly for those who have flown before, commanders of both crews. What are you lacking most on board of the ISS, and what do you think you will be missing the most? Maybe something interesting or unusual? Of course, we miss our families the most. But we are lucky in a way because our flight will only be 4 months long, so it's going to be easier for us. For me, I heard that the best part of space flight for rookie is to see Earth. We have cupola, we have a lot of windows, and we can see our planet. I think it will be very interesting. Personally, for me, it's very interesting to see the Earth from space, because everybody who came back from their expeditions says that the Earth looks very beautiful from space. So I'm very excited to soon be able to see all of this with my own eyes. I hope that on orbit it will be interesting to do scientific research. That's very important to me. Pesquet and Takuya were saying it's true. I love seeing the Earth because it's beautiful. I agree, seeing the Earth is mesmerizing. It's something that you cannot describe, even if you use any of these wonderful cameras. What we would miss, of course, is our families, gravity, and the smell of fresh leaves. So the question was, what are we going to miss the most? I would say French cheese for me, because the food on board of the ISS is all right, but for a French person, it would be too boring. Thank you to Japanese. In this company, question for everybody. I know you're going to be very busy in space, but if you have free time, what are you planning to do? Maybe cook something for everybody or do something else? All right. Well, thanks for the question. Based on my previous spaceflight experience, I can tell you that all of the free time I was busy taking pictures of the Earth. This is the process that requires a lot of time. you try to photograph Earth, you try to understand what you photographed, you edit the pictures, and despite the fact that there is special time allocated for rest and recreation, all of my free time was spent still photographing the Earth, although I had never been an avid photographer or anything. Once I found myself in such a unique location, that was something that I really enjoyed doing. That is correct. Not much free time in space, but I would say that it's strange, but I think it would be interesting to do science experiments. I plan to do science even in my free time. I plan to take pictures and video for students of schools and universities to show how we live in space, how we perform experiments, how we do a lot of interesting things in space in the absence of gravity. Our expedition will be a little shorter than usual, only 4 months. So I think that all free time, of which we won't have much, but if we do have free time, all of it, I look forward to just simple things, everything that happens, eating, sleeping, working in space, watching the Earth, everything sounds very exciting. Thank you very much. We have time for 2 more questions. Hello, my question is for the Prime crew. What will be the call sign for the crew, and why did you select that call sign? Well, the selection of it is a complicated issue. My background is military aviation, and so things were simple at that time. Our call sign would change regularly, and it was just a 5-digit number. That's it. So no headache, no worrying. Now here we have the tradition that the crew selects its own call sign, and I talked to my wife and asked her to help me select one. So Irkut is our call sign, which is the name of the river in my hometown. Okay. Also, what are you planning to bring? What personal items are you planning to bring on board with you? That's true. We're allowed to take some personal possessions. I'm bringing our wedding bands. For me, it will be photographs of my family and something to demonstrate for photo and video. I will bring personal items such as photos of my family, of course, music, etc. Thank you. Asahi, Japanese newspaper. My question is for everybody, but of course for Onishi-san. You said that you wanted to be an astronaut since you were a child. Do you have any advice for the children who are dreaming of becoming astronauts now? In Japan, of course, everybody will be following the work of Onishi-san. So what would you recommend to those who want to be astronauts? Maybe study Russian? I think what helped me to become an astronaut is my experience. What I do, what I don't want to do, what I know I don't do very well. Learning about this, my strengths and weaknesses, really helped me in becoming an astronaut. So I recommend to the children to try to do everything right now and see what your inclinations are. I would recommend to children to be good students and athletes, be active. These days, you can have any professional background and still become an astronaut. So it doesn't matter what profession you choose. Just try to succeed in whatever field you choose. Mathematics and science are very important, but I think also my advice would be to do something that interests you the most. Because what's important is to be interested in your job, in your profession. Just study something, and that's very important. That's my advice. Thank you very much. Last question. Okay, last question. What allows you to become a united single crew, seeing that you come from different backgrounds?
Чувство юмора является совершенно необходимым в любой профессии, в том числе.
Well,
сложно сказать, какие качества нам.
That is something that any profession can benefit from.
Не задумывались, просто.
How did we become a single crew? I don't know. We really didn't give it much thought. We just worked it out. I think humor is very important because we will be spending a lot of time together and we will have many difficult tasks. So we should try to work together very well, and I think our crew has always worked well together. We work as a team in a very calm manner. And of course, we do all have a good sense of humor. And we have a very experienced cosmonaut who's our commander. He's always calm, serious, and knowledgeable. He's calm even when there is a fire or deep breath. And so I like his style. Also, for Kate, she is a serious biologist. I'm a pilot, and I think that we complement each other very well. I am very happy that I will be in space with such a crew. Thank you. Thank you. We are very impressed with your great knowledge of the Russian language. Okay, can you shake hands, please? Thank you.